Yeah. Okay. Yeah. Hello everyone. Let's get started with the current affairs of last week. Okay, of science and tech. Now, this is the first topic. This is coal plant inflexibility. Now, what is this? Let's understand. So there was one article in Indian Express. Mainly, this is about mains. Okay. Now, we'll understand what is the issue. Now, it says, why are coal-fired power plants becoming a bottleneck for India's renewable energy push? Okay, now it may seem odd to you, correct, that there is some problem with our thermal power plants or coal-fired power plants. Now, how is that affecting? How is that affecting our renewable energy push? Okay, now first thing, see, India's renewable energy capacity reached 262 gigawatt in 2025. Then renewable energy now forms more than 51% of installed power capacity in India. Installed power. There is a difference. Okay, it is not being produced. This is the installed power. Now, but solar generation peaks during daytime. Thermal plants must reduce output. Now, many coal plants cannot operate below 55% minimum technical load. Result, excess renewable electricity is curtailed. Now, understand the whole issue. See what is happening here. If you talk about renewable energy, now renewable energy is available more at a particular time, correct, and almost nil or very low at some other time. Now, the problem that we are facing is that, for example, during the daytime, when there is sun, correct, when the sun is there. Now, the problem that we face here is, in spite of having sun, we are still dependent on coal. Why? Because see, there is a minimum threshold that these coal power plants want. Otherwise, what will happen? Understand, because the grid is same, correct. So this grid is same grid, that is the electricity connection from the power plants to your houses. This grid is same. Now, they are not able to change the load in this grid. Okay, so if it goes below something minimum, or if it takes more of renewable energy, then it can hurt the existing infrastructure, that is the transformers and everything. So what they have to do, they have to maintain a minimum. Even though sunlight and renewable energy is available, they have to get a certain amount, for example 55% MTL here, from the thermal plants only, and that is a problem. Understood why we have a problem like this? Now, because of this, what will happen? So a lot of solar energy may be generated, but they have to be stored, correct, they have to be stored at some big, like big batteries or something like this, because they are not being used at that time. It is not that India does not use that much energy, correct. So in daytime, whatever is our installed capacity for solar energy, it is much less than our demand daily, correct. So we can meet more of our demand using renewable energy. But why we are not able to? Because of the limitations in our grid and thermal plants flexibility. Understood? A very intricate issue, can be a very good point in your means, correct. Now, let's see next thing. Yeah, what is renewable energy curtailment and its impact? So curtailment means intentional reduction of renewable energy electricity generation. It can generate more, but we are curtailing it. Then India lost around 2.3 terawatt hour solar electricity due to curtailment. Terawatt hour, you understand? 2.3 into 10 to the power 9 kilowatt hour. What you know as kitne watt electricity, kitne unit electricity I, you say this now. So this is 1 unit. So how much we are curtailing? 2.3 into 10 to the power 9 units. Then now this is enough to power nearly 14 lakh households annually. Okay. Just a second. Yeah, then next thing is, see, renewable energy generators compensated under TRAS mechanism. So now basically what is happening now, that these generators have to be compensated. Why? Because they are generating a lot of energy, but they are not utilized by the grid as such. Then consumers indirectly bear compensation cost through tariffs. Understood? Same issue, how much we are losing. If you can remember this one data, it will be very useful. That because of renewable energy curtailment caused by inflexibility of our thermal power plants, we lose 2.3 into 10 to the power 9 kilowatt hours of solar electricity. This can be used as a good example. Then next is, what are the major grid stability concerns? So what are the concerns? So India operates a unified national grid. Okay, we have understood this unified national grid. That is same for the solar also, same for everything. Now see this. Safe system frequency is around 449 to 50. If you remember, we say that India has particular fixation at 50 hertz, correct? Now what happens? Inflexible coal plants create supply demand imbalance during peak solar hours, because they are not flexible. What they should ideally do? They should suddenly reduce the output from thermal power plants and then get more from solar. Then high frequency conditions threaten safe grid operations. That is why we are dependent. Around 10 gigawatt solar power had to be curtailed. This we have seen. Understood? Then next, now why are these companies, thermal power companies, they are resisting flexibility reforms? Why they are doing this? So operating below 55% load causes what issues? So if they go below 55%, it causes boiler and turbine stress, higher wear and tear, reduced plant lifespan. So everything is actually developed to generate a minimum also and a maximum also. Maximum we have focused since a very long time. The minimum threshold is also there. Now that flexibility we need in our thermal power plants. Otherwise, whatever we keep talking about, that this way we can generate more renewable, this way we can generate more solar, this, that. But what if we are not able to use it? Correct? So this is an important issue. Then older thermal plants are specially vulnerable. NTPC cited poor coal quality and ramping issues as to why they are not reducing the thermal power generation during those hours when renewable energy is abundantly available. Then what is the way forward? Yeah, so see, Central Electricity Authority CEA should propose some incentivizing mechanism, some scheme, so that they try to do this. Okay, flexible coal technology, that if some company, most of these are run by the government, if they are given some, if they want to do some technologies, some adopt some technology related to flexible coal technology, then they should be given some subsidies and something like that. Battery energy storage system. What is this BES? Battery energy storage system, very important. This is those very big batteries you might have seen, correct? That can store renewable energy for a long time. Those are called BESS. There also they can invest. Then pumped hydro storage. This was also PYQ. Pumped hydro storage, what you do? When you have excess energy, what you do? You take the water on surface like this to the top of the dam using an electric motor, correct? The motor will take this water up. Now whenever electricity is needed, you can drop this water and get electricity out of it by turning the turbine. So this is called pumped hydro storage. This was also a question, I think, in 2023 prelims. Then Smart grid management, yes, correct. So that it is flexible, reduce and increase whenever needed, whenever renewable is available or unavailable. Then important for achieving 500 gigawatt non-fossil fuel target by 2030. If you remember, this comes from Panchamrit. This comes from Panchamrit, correct? 500 gigawatt by 2030. Understood? Then next is this. This is Chandrayaan 3 HOP experiment that reveals regolith heterogeneity at Moon's south pole. Now, let's see this. So basically, now, what is Chandrayaan 3 HOP experiment? Now, Chandrayaan 3 you must know, correct? The mission where we sent a lander and rover, all that, successfully to the south pole of the moon, correct? Now, what is this? This we'll understand. Now, what was the Chandrayaan 3 HOP experiment? What was this experiment? So Vikram lander, if you remember, fired engines using residual propellant. Now, see this. So, if this is surface of moon, now this Vikram had landed on it, correct? This you remember. So Vikram is going around on this surface of moon, but it had some amount of propellant left. Now, through this, they did one HOP experiment. HOP experiment will do what? So that this lander rises a little and then goes to some other place and then lands there. Not very far, not much high distance, but just hop and land somewhere else. Correct? So, this was to test how the soil responds to the lander and do some observations related to it. So, this was a hop experiment. Hop means small jump. Then formed a small hop of nearly 50 centimeter. Very small, correct? 50 centimeter, correct? Then helped scientists study lunar surface behavior at another location. So it went from one location to another and there they could study lunar surface. Conducted after successful lunar landing mission, as you remember. Then next, what is Cheste experiment? Now, what is this? See the full form. Chandra's surface thermophysical experiment. Now, this Chandra here means Chandra, okay, what we call Chand or moon. Now, this is surface thermophysical experiment. This is the official name of that experiment. Okay, now, so what they did, they had instrument that carried temperature sensors, heating probe. Probe penetrated lunar regolith to study thermal properties and surface temperature variation. So what this does, it basically penetrated. So this is, let's say, the lunar regolith. Basically, like you have land on soil on earth. Similarly, this is regolith. Now, so it penetrated it, correct, to collect some information about the thermal properties and the surface properties, surface temperature, and even slightly about how hard is the surface, okay, or how hard are the layers inside it. All this they did using this experiment. Understood? Remember this experiment name and what it did. Just overview. Then what is lunar regolith? What is lunar regolith? Now, moon's surface layer is called lunar regolith, not lunar soil. Correct? Then consists of what? It consists of shattered rocks, dust particles, jagged glass-like fragments. All these three combine to form regolith. Then formed due to continuous meteoroid impacts. So it is said that what used to happen for millions of years, what has happened, that meteoroids and everything has fallen on moon, and then it broke down. Okay, so parts of it remain there, then slowly sometimes they become dust over time. So that is what the surface of the moon looks like. On the surface you have all this. Okay, now, so this is the moon's surface layer. That is formed because of its interaction with other celestial bodies. Now, next is major findings of the experiment. So what it did, it revealed that there is a two-layered cake-like structure beneath the lunar surface. Cake-like structure. Why it is saying cake-like structure? Because the upper layer actually, just like you have in cake, no, that this is like bread, some form of bread, correct? And above it, what you have? You have cheese or frost or something like this. This is what your cake looks like. Now, in the moon also, it is very similar, that the upper layer is soft, correct? That is formed because of impacts and this and that. And the lower layer or the layer inside is very hard, much more compact and hard in, just like the cake is. Now, see this, upper 2 to 6 centimeters layer found highly porous, correct? Then mainly dust and all, highly porous, sticky, cohesive. Sticky and cohesive. You understand both these words, correct? So basically sticky in that sense and porous. Now, bulk density, see, it is much lower here, but it slowly increases to this. Now, this is important for water ice storage studies, lunar habitat planning, and rocket plume interaction studies. So basically, see, ultimate, if you don't want to go in detail, see, we as humans, we want to settle on moon, correct? Eventually we want to make permanent bases on moon. Now, our understanding of the structure, okay, surface of moon is very important. Otherwise, how we will construct anything above it, correct? How we will manage that, how much dust will be released whenever we land this much object on that, correct? So all these things need to be calculated. Even for making a building, they have to test a lot of things. They have to do a lot of soil testing, if you know. Okay, they want to make a building of 30 floors, they do a lot of soil testing. It goes to labs to identify that is there enough support that will be available, or will this be stable, then only they go forward. So here also, if we want to settle on moon, then we need all these studies. Okay, then why are these findings important? So as I told you, this helps us understand lunar surface stability, thermal behavior, surface erosion, geotechnical variability. This is useful for future lunar bases, human habitation planning, and site selection for moon missions, correct? So that we understand that which sites are safe, where we can land, what structures we can make over it. All these require understanding of moon structure. All of these. Okay, then next. Yeah, next we come to the topic is Raman scattering. Okay, so this I have picked from PIB. So in PIB, the honorable minister, he went to a center. Okay, now that is the same institution where Mr. C.V. Raman found out this effect. This is called Raman effect. We'll understand it. Now, okay, so This is about C.V. Raman. Now, this is of course, this is a major scientific, ICAS is a major scientific institution. That is just for your context. Main thing that we have to study here is about Raman scattering. Now, so this was founded in 1786, all this, India's first modern scientific research institution. This is the birthplace of Raman effect. Okay, so in PIB what they did, they started that the minister went there, and after that they said that this is the place where Raman scattering, all that was developed. So we are also doing this. Then Sir C.V. Raman's work led to India's first Nobel Prize in Science. Then associated, this institution is also associated with Jagdish Chandra Bose, Meghnad Saha, S.N. Bose, Satyendranath Bose, all these. Then now, what is Raman effect? This we need to understand. See, change in wavelength of light after scattering by molecules. Now, let's understand scattering in terms like this. See, the most famous and the one that you might have seen, may not know by the name, is called Rayleigh scattering. Okay, now what is Rayleigh scattering? So basically here what happens, some laser, some light comes, collides with this molecule, okay, some molecule, and it goes away with the same wavelength. This is what normally happens. This is what normally happens to light, that light comes, collides with, let's say, a molecule, and then is reflected in the same wavelength. That is lambda of laser. Lambda means wavelength. Okay. Lambda here is a representation of wavelength. So lambda of laser is equals to lambda that is scattered. So wavelength remains same. This is Rayleigh scattering. Now understand this. This is called Stokes-Raman scattering. Now Raman scattering says what? That what we have assumed that at those times we had assumed that whatever is the lambda or wavelength of this laser, now same will be reflected away, nothing will change. But he observed that in some rare cases this can change. So what will happen? According to Stokes-Raman scattering, for example, this is a laser. This molecule is chilling, okay, it is at low energy. Chilling is at low energy. Now what will happen? When this laser collides with this molecule will absorb some energy. Again, when this laser collides with the molecules absorb some energy. Now that means what? This wave, this laser will now have lesser energy. Now one formula you must know, E is equals to hc by lambda, or energy and wavelength are inversely proportional. Correct? They are inversely proportional to each other. That is, if you see here lesser energy is there with the laser, so if this is decreasing, then what will increase? Lambda will increase. Correct? So the laser that came here collided with the particle and then went away. So this scatter will have greater lambda than the original laser. Why? Because it lost some energy to the molecule. Understood? So now if the lambda changes, if you remember, by lambda what we define? We define color of light using lambda. So that's why you see color has also changed. So it was, let's say, green color, now it has become red color. Why red color? Because red color has higher wavelength. Remember this, that if I draw, then it used to be like this. Correct? This used to be higher wavelength. In this direction wavelength used to increase. So R or red has the highest wavelength. That's why here wavelength increased, energy decreased. Correct? So wavelength increased, that's why it looks red to you. Now the opposite of this effect is called anti-Stokes. This is also coming from the same Raman effect. That is, when light interacts with molecules, it can change its wavelength in some cases. Correct? Now what is anti-Stokes? So in this case, now let's say the laser is coming, the molecule, let me change it to blue. Yeah, let's say the molecule in this case is already very excited. Now what will happen? If a laser comes like this, then it won't absorb energy from laser. In fact, it will give more energy to the laser. Now, if again, if energy is inversely proportional to lambda, now if suddenly, this is all I am talking about laser, if suddenly the energy of laser increases, then lambda would decrease. Lambda decrease means that you will have lambda of laser become greater than that of the scatter. Understood? So this is the anti-Stokes-Raman scattering, and this was Stokes-Raman scattering. Okay, now why is this important? Because what is being scattered, okay, how the wavelength is changing, that tells us a lot about the properties of that compound. Understood? So property of those molecules, compounds, or any substance, that we get to know using Raman spectroscopy. This is called Raman scattering. Then we do something known as Raman spectroscopy or spectroscopy, in which we try to learn what is the substance composed of using these properties. Understood the whole phenomena? Okay. Now, once you understand this, now it's nothing. If you want to draw, you can draw this. Then next, yeah, this we have done. Raman effect, yes. So change in wavelength of light after scattering by molecules is not zero. This is Raman effect. Now it may increase or decrease, all that is fine. So you have understood all the terms related to it. Now, discovered by Sir C.V. Raman, now led to Nobel Prize. Basis of Raman spectroscopy, as you understood, material and chemical analysis. Understood all the terms, everything. Now, next. How does Raman effect work? How does it work? See, when monochromatic light falls on a molecule, most scattered light has the same wavelength. Small fraction changes wavelength after energy exchange. If molecule gains energy, scattered light loses energy, longer wavelength. If light gains energy, shorter wavelength. Correct? This helps to identify molecular structure and composition of a substance. Everything, each word here you have understood. Then next, what major facilities were inaugurated at IACS? Now, see this. I'm forgetting this. Yes, so the full form actually is Indian Association for Cultivation of Science. Little weird. Okay, this is Indian Association for Cultivation of Science. Very old institution, called the oldest research institution in India. Now, so what they have done recently, they have installed indigenous plasma enhanced chemical vapor deposition system. Okay, now what is this plasma enhanced? See, What is plasma? Plasma is what? Plasma is super ionized gases. Correct? Plasma is super ionized gases. Now, what it says? Plasma enhanced chemical vapor deposition. So, plasma is enhancing. Now, CVD, chemical vapor deposition, is making of anything. For example, nanomaterials, bottom up. So, basically using gas, they will deposit it slowly. Now, if you use plasma, that is ionized gases, it enhances whatever you are trying to manufacture. Okay, so this is called PECVD systems. Now, this is used for fabrication of India's first amorphous silicon solar cell. Now, what is this? See, solar cell, you understand, correct, which can show photoelectric effect. Now, in that, what you use silicon. That also, you know, in PV cells we use silicon wafers, all that. Now, what is amorphous silicon? So, silicon usually has a proper structure, correct. Now, amorphous form is which does not have a proper structure. Some weird forms it may have. Now, it may show some better properties also. So, this is India's first amorphous silicon solar cell. Now, new incubation center has been launched, which is Retina. Retina is research, entrepreneurship for translation, innovation and navigation. This is just something that is made up. Okay, then next. What are the major research areas at IAS? So, what are the major research? Not very important. Quantum, nano, AI, battery material, cancer biology, environment tech, biosensor, photo detectors, toxic waste remedies. It was all given in the PIB. So, I have written, otherwise this is fine. So, basically this is a very advanced research institute and it has most of the things they are working on. It is the first research institute of India that you remember. Then, because now they have gotten interested in biography of scientists, they asked that John Clark question, okay, that this Nobel laureate, this, that, okay. So maybe they will ask this also, that C.V. Raman, okay, which of the following statements are true about IAS? Okay, the full form itself is weird, correct, Indian Association for Cultivation of Science. This you might feel is wrong. Then the second thing they will tell is that in this institution is where Raman discovered Raman scattering effect, correct. Now that is also weird for you to know. And the thing is that they can very easily ask that which of the following, or and last statement, that this is the first research institute in India. Again, seems like wrong, but it is also correct. So can be made into a question. Then now India shortlists 3 old thermal plant sites for conversion into nuclear projects. Okay, this was recently in news. It was mentioned again in PIB as well. So what we are doing? We call for, we first called for proposals from different thermal power plants which are not working very well now or completely defunct, and we want to convert them into nuclear power plant. Now, why we want to do that? All that we'll understand. So, this is the news. India has shortlisted 3 old thermal power plant sites for conversion into nuclear power projects as part of its plan to expand civil nuclear capacity and repurpose aging coal infrastructure. Understood? Now, why is India repurposing old thermal power plant sites for nuclear projects? Why is India doing this? Now, first, India aims to expand nuclear capacity from 8.8 gigawatt electric to 100 gigawatt electric by 2047. Correct? This is fine. Then, old coal plants face rising emissions and aging infrastructure. Fine. Then, existing sites already have land, water and transmission infrastructure, okay, and supports clean energy mission. So what they are saying that old coal plants, they are anyway aging, they do a lot of emissions, they are not good for us, whether with respect to efficiency or with respect to sustainability. So what we should rather do, we should just make them nuclear plants instead. Why? Because other infrastructure that is needed, maybe for cooling, okay, maybe for example for transferring energy to the grid, all that is already established. Correct? So land acquisition is a very difficult or challenging issue in India. So land, water, transmission infrastructure, everything is in place. So we should just convert them into nuclear power plants. This is the core thing. Now, next, what is Shanti Act? Shanti Act, you know, this is Sustainable Harnessing and Advancement of Nuclear Energy for Transforming India. Shanti Act, passed in December 2025, allows private sector participation in nuclear plant operation, fuel management activities. Correct? Mainly for nuclear energy generation only, nothing related to nuclear weapon, this, that, nothing. Okay, then what are the key findings of site selection exercise? Now, government shortlisted 3 thermal power plant sites, 2 sites suitable for 700 megawatt reactors, 1 site for 220 megawatt reactors. Evaluation was based on water availability, land, seismic safety, population density. So they have found 3 of these sites. I think there was 28 proposals, from that they have chosen 3. 2 of them are little bigger. 220 megawatt is anything less than 300 megawatt can be small modular reactor. Understood? Then next, what are exclusion zone requirements and why are they a challenge? See, nuclear plants require mandatory safety buffer around reactors. So usual present exclusion zone is 1 kilometer radius. Habitation or economic activity is not allowed within this zone. Major obstacle in converting old thermal sites into nuclear sites. Now the thing is, if you might have been to NTPC, SECL, all these, okay, thermal power plants, just around the thermal power plant they have an entire colony where people live. There are villages around it. Why? Because there is no such restriction in thermal power plant that for 1 kilometer there can't be anything. In fact, around that in 1 kilometer there are many things. Correct? So that is a major obstacle, because if you are converting it, now how do you ask all those people that are there around in 1 kilometer, how do you rehabilitate them? That becomes a major challenge. Then government considering revised norms of 700 meters for 700 megawatt reactors and 500 meters for 220 megawatt reactors. So what government is saying, that 1 kilometer is too much, so we can, instead of rehabilitating a lot of people, nuclear power plants are usually safe now, so we should change the norms itself. Now of course there will be a lot of activism against it, that this being that close is not safe, all that will go on. Now we'll see what happens. Last, why are small modular reactors important for India? So repurposed thermal sites may suit small reactors better. Why? Now you understand. Because of that 1 kilometer is the requirement for those large nuclear power plants, but not so much for small modular reactors. Correct? Small modular reactors, because they are less than 300 megawatt and they have changed the norm for that, they can be installed there without changing a lot of things. So that is why this becomes important. Then the next thing is SMRs need less land, small exclusion zones. Correct? Understood this. Lower water requirement. Correct? Because the cooling requirement of thermal and nuclear is also different. So if it is smaller, then the cooling requirement will also be taken care of. This is useful for gradual clean energy transition of aging coal infrastructure. So for aging coal infrastructure transition, this can be a very good method. Also it will promote small modular reactors, that has been mentioned. many times in the budget as well as economic survey. So very important, India is focusing on this. For this only we have opened our private sector, the small modular reactors, and this can be another place or another site where small modular reactors can be installed. Understood? This is the first one and this last one. Both of these are very good points for for your mains. Correct? This also you can quote that for nuclear power plants you have many issues, this, that, small modular reactors. So in one of the solutions what you can do, you can say that thermal power plants, the old defunct inefficient thermal power plants, can be converted into small modular reactors that can act as a nuclear energy generation plant. And the first one that we read, that there should be flexibility in coal powered plants or thermal power plants so that renewable energy can be used more. Otherwise, a lot is being generated or can be generated, but we are not harnessing its full potential. Understood? Two nuanced point will enrich your answer a lot. Okay, so I think this is it for your science and tech current affairs this week. Thank you.